Recording has started. Good afternoon to everyone, and we'll make a start. So, we're finished. Last week we would have finished with chapter 9.2, but to give us a general recap, remember we first started with our overall goal is to create a program. Our overall goal is to create a program, but we don't just go and create a program just like that. We have to do some tasks before that. And one of the, such tasks is what is called the problem solving, or more so, a problem definition. So I should have given you guys this to do for your SBA, to start it for your SBA. I'm going to give it to you for you to start it now. Before we begin, we can read through the programming part of your SBA so that you have a general idea. So notice there's a problem solving section, and then there's a program implementation. So it's similar to the algorithm and the implementation phase. So the algorithm phase is basically this first part here. And then the implementation phase, that's this second part of your SBA. So the first part is to develop an algorithm. So that's why we're covering these chapters here, so that you can know how to create an algorithm for your program. So develop an algorithm to print the names of the candidates who should receive a refund. A refund is due if the candidate's vote received equals or exceeds 20% of the votes cast in the constituency. The algorithm should also determine and print the number of candidates who received the refund. Now, this part here, test the algorithm with data from 10 candidates. This data is going to come from your spreadsheet. The algorithm must accept as input the names of the candidates, votes received, votes cast. The algorithm should print the name of the candidate and the words refund or refund due and the number of candidates who received a refund. Data to test the algorithm must be sourced from the spreadsheet section of the project. So before we create an algorithm, as we would have learned, what do we create before we create an algorithm? What do we create before the algorithm?
Find the problem?
Yeah, we figure out what's the problem. But after that, a simple table that we would normally create for the algorithm. Actually, just gave a hint. What table do we create before the algorithm? A 3-column table. I gave you too much hints, you know.
You get an input, process, and output.
So what do we call that?
The IPO table.
The IPO charts. Yes. Good. So, two things I want you to start for your SBA, your programming part of your SBA. I want you to create your IPO charts. We would have already practiced how to create IPO charts. Remember, it's a simple 3-column table for you to document what is your input, what is your processing, and what is your output. So based on this information here, this paragraph, you can figure out what is your input. It clearly says what is your input. So I'm not going to tell you as yet. I'm going to see if you can figure it out first. Document what is your input, what is your processing, and what is your output. So I want you to create your IPO chart. Any questions? Good.
No, sir.
Very good. So once again, remember IPO chart, you document input, processing, output. You're going to get that information from this paragraph here. Same thing that we would have done so far. Now, as Amlina said, before we actually reach that stage, we need a problem. So we need what is called a problem statement. Or some people would say a problem definition. Because you're defining the problem, you're explaining the problem. So this is simply a paragraph kind of write-up. It's something you describe. So in a Word document, the IPO chart, you can do it in a Word document also, because you're going to continue with the IPO chart after that, the algorithm in that Word document. So the IPO chart, you started in one Word document, and then your problem statement, you start that in another Word document. So the second task for your program in SBA is for you to create a problem statement or definition. Same thing we would have covered. You have to define the problem. Anybody remember how we define a problem? What are some key information that we have to look at when we're defining a problem?
Possible outcomes.
Possible outcomes. All right. All right, problem statements. So this is going to be the structure of your problem statement. So first paragraph, what is the, so an introduction, obviously. Introduction. What is the issue? What are the causes and the effects of the issue? So that's the first paragraph. So you give a general introduction, and then you go into what is the issue at hand? What issue are we facing? What would have caused that issue? And what are the effects of that issue? Now, how are you going to get that information? Well, if you read the first paragraph of the SBA, it can give you some idea. So you can go through it. It says that national general elections have been a recurrent feature among the democratic territories of the Caribbean. Every year, in one territory or another, citizens exercise their right to elect a government of their choice. However, the exercise is not without its attendant challenges of data management. Thousands of votes are cast on the day of elections, and an anxious waiting public demands speed, efficiency, and accuracy in the determination of the results. So, all it's basically saying is that they want the data during these elections. They want to get back the results quickly. They want to, and at the same time, they want to ensure that it's accurate, it's efficient, it has a system that won't break down It has a system that would get them the results even though it is fast. So it doesn't necessarily say what is the issue, but you can think up of a few reasons as to what can be an issue. So let me see if you can think of something. What could be an issue that would cause the elections to not be fast, to not be efficient, to not be accurate? And that you have to go and create this program to fix it. What could be an issue? What could be a possible issue?
Fraud?
Huh?
A fraud?
A fraud? What do you mean a fraud?
Like if a vote was miscounted or something?
Yeah, yeah. But I'm looking more for like I'm looking more like a general kind of idea. They want you to create this program to make the elections work faster, to be more efficient, to be more accurate. What would that mean in terms of what they already have, the old system? All right, so it would simply mean that the older system, it's not fast, it's not as efficient, it's not as accurate. So they have an old system. So this is the old system, and they want you to create a new system to run the elections. Now this old system is not fast, it's a bit slow. It more than likely gives you the results, but maybe it takes 2 days, 3 days, what's not. The new system, it might do it within a few minutes. So that's why you're creating it. So what could be some reason, or what could be the system? What could be the reason why this old system is taking so long? It's not as efficient. What reason can you come up with? Why is this? Yes, go ahead.
Said because too much data information is being processed at once.
Uh-huh. That's it?
That could be a reason why it's moving slow.
So is it all right? Maybe you're not um, fully understanding the question, but in line with what you said, though, yes, we have to process a lot of information. But what would make this older system not be able to process as fast as the newer system? So obviously they're gonna process the same amount of data, same data. But what would make this older system not process the same amount of same amount of data efficiently as the newer system? What are some reasons now?
The old system could have too much steps to go through.
All right, good. It has too much steps. So then we can simply say that the older system, it's an outdated system. Maybe it's a old program that was created maybe in the we did 2023. Maybe it was created in 2000, or maybe it was created in the 1900s. Not 1900, the 1990s or 1980s or something. So one issue could be that the system that they're currently using is an outdated system, and there are different things that you can look at. Maybe it's an old program that was, like I said, created in the early 2000s, maybe the 90s, the 80s, and so on. And like you said, it's not as efficient. It has too much steps. So they assign you to create a newer program. That could be one reason. That could be one issue. Another issue could be that maybe they do not have a computer setup. Maybe it's a manual setup, like what we have here, I think, in Guyana, whereby you go and mark on a piece of paper, and then people go and physically count it. So they don't have a computerized system. Maybe that is the old system. You guys get where I'm going at? You think you're following?
Yes, sir.
So what you're basically doing is coming up with some sort of idea, some sort of reason why the old system is not as efficient. Any reason can work once it makes sense. Any reason can work, and they don't mention an issue here. So what is the issue? The system is old, the system is inefficient, the system is slow. Why? Maybe it's an outdated program. Maybe they do not have a computer system. There's so many other reasons. Maybe the persons don't know how to use the program properly. Whatever the reason is. So start with a general introduction. This same paragraph here can give you some idea how you can come up with an introduction, because you can use information from the paragraph. Then what is the issue? That's what we were just talking about. What is the general issue? The system outdated? How is it outdated? Is there no system? Is it the old program? Is it the old computer? What is the issue? Now, what are the causes? It causes the elections to be slow, outdated. People got to wait days to get results. What are the effects of that? People get angry, they get frustrated, they start to riot. So that's your first paragraph there. Any questions?
No, sir.
No, sir.
Now, your second paragraph, you're going to start off with, what is your solution? So what's the solution?
Make a new program.
Exactly, to make a new program. So we know what is our solution. Our solution is to make a program. Now, you have to describe this program now. So this is where we go back to chapter 1. So this is where we go to defining the problem. And these steps here on the right hand side is what you can use for describing your solution. So what is your solution? Describe your solution in terms of input, processing, output, and storage, if it does storage or not. So you describe how your solution is going to work. Describe how the solution works. So you describe, and by describing how the solution works, you do that by indicating what you have to input, how is it going to process that input, what output it's going to give you, and then if you're going to store any data or not. And then you close off with the benefits. Benefits of the solution, and then you conclude. And that there is your problem statement or your problem definition. So you're basically giving us a description of the issue to solution. That's the purpose of the problem statement. So when a person reads this document now, they'll know what you're trying to solve, what you're trying to do, why you're doing it, how you're going to go about solving the issue, and so on with this documentation. So once again, first paragraph, introduce, give a general introduction about the situation. Introduce the issue. What is the issue? What are the causes of the issue? what are the effects. Then you mention how you're going to solve the issue, what is your solution, describe how your solution is going to work, and how we are going to benefit from this solution, how is it better than the old system, and then you conclude. That is your problem statement, your problem definition. Are we clear?
Yes, sir.
Amelina?
Yes, sir.
All right. Any questions?
No, sir.
All right. Good. So that's two things you need to start for your programming part of your SBA. Your problem statement is one, and your IPO charts. So from your problem statement, you can get the information from the first paragraph of your SBA, and in the programming description of your SBA, you'll get the information for your IPO chart. If you're working on it, you can send me pictures of it, and I can guide you and tell you where you're going with it, the IPO chart and the problem statement. How you can do to improve it, or if you're going in the right direction. All right, good. So with that in mind, let's continue with our class, with our content. So as mentioned, a revision of what we would have covered. So we would have already covered what is the how to solve a problem, what is the IPO chart. We would have looked at how to design an algorithm. What are the parts of an algorithm basically, like what is a variable, what is a constant. We would have actually looked at some examples of designing an algorithm. We looked at what is a statement, what is a keyword, conditional statement, loops, subroutines, and so on. So today we're going to be starting chapter 9.3, where we're going to be looking at how to develop a pseudocode. So this is another part of your SBA, but obviously you're going to work on it when we're finished with the chapter, or as we're going through it, you can start working it also. But that's why you should try to complete your IPO chart as soon as possible, so that you can also work on your pseudocode, because your pseudocode comes right after your IPO chart. The pseudocode is basically, if you guys can remember, is a type of algorithm. Not a type of algorithm, but a way of representing your algorithm. There are different methods of representing your algorithm. The pseudocode or flowchart. And we're going to be focusing on how to create that pseudocode. So for your SBA, we're going to be creating a pseudocode, not an algorithm. So we're actually going to need to know how to follow the rules of creating a pseudocode. So to begin, a pseudocode, firstly, is not a programming code. So a programming code or a programming language is what you use to create a program. A pseudocode is not a program. It's simply a guide. So it is not a programming code, but it uses English type words and phrases that are clear enough to be easily converted into programming code. So that is why the pseudocode, it has certain guidelines as to how to create it, so that when you're going to convert it now to a programming language or a programming code, it should be an easy conversion, because you should be able to convert it to any programming language. That's how it should be written. Where it should be written in such a way anyone can be able to convert it into any programming language. It's not going to be specific to one programming language. the paragraph continues. It uses the same statements, keywords, variables, conditional statements, and loops described in the previous section to create the instructions for a solution to a programming problem. So the same terms that we would have learned about: what is a variable, how to create a variable, what are the types of variables, what is the various statements and keywords that we can use, and what meaning they have, what action they carry out. Those statements, those keywords, those actions are what we're going to be using in the pseudocode. Now, a pseudocode can also be developed from an IPO chart. So that's what we're going to be doing. We're going to create an IPO chart and then develop our pseudocode from it to specify what data is input and processed into information. So let's first review the IPO chart that finds the sum of three numbers. So we already went through this IPO chart in the previous chapters. So first column, we have three variables. We have variable number 1, variable number 2, variable number 3. And they are named number 1, number 2, and number 3 because we are finding the sum of three numbers. So we have three different variables. Now, the processing is basically calculation. How are we going to convert inputs into outputs? So we need to add the three numbers together. That's simply as num1 plus num2 plus num3. And then we output the result of that calculation. Are we clear in this IPO chart?
Yes, sir.
Yes.
Great. All right, so we're just going to brush through this paragraph because the same thing I would have just explained. But this part here is good to note that the keywords input and output are used to indicate that data is input. So the keyword input, data is input. But how? Usually using an input device such as a keyboard. So whenever we say we use the keyword input, yes, we're indicating that data is going to be put into the program, but how is it going to be put into the program? Is an indication that the person is going to be typing in the data. There are different methods of input, but we're only going to focus on this one method, in that the person is going to be typing in the information, while the output can be as a soft copy to the screen of the monitor. So soft copy in that we're seeing it digital on the screen. So the keyword end or stop denotes the end of the statements. So I think we would have looked at that here when I was showing you the parts of an algorithm, that the algorithm starts with a title. As we can see here, the algorithm has a title here, and the algorithm always ends with the keyword end or stop. That's how we know it as the end of the algorithm or the pseudocode. It has that keyword end or stop. If we do not see that, then we basically won't know where it is ending. So, example 5. So this is an actual algorithm here. So the starting point of the algorithm is the title. As I would have told you guys, you can use the right after the title if you want to put in the word start. If you want to put in the word start, like right there, to indicate that is also the start of your algorithm, no problem. Nothing's wrong with that. But usually the title is an indication of the starting of your algorithm. So you have pseudocode 5a colon. So in your case, it's going to be pseudocode colon and then a title. That's how you are going to create your title. This is how your pseudocode is going to start. So when it comes time for you to create your pseudocode, you can look back at these same examples and follow the pattern as to how they would have created it. And use your IPO chart and follow the same. So we have a title. You can insert start. This is optional. Now, remember, we always follow the cycle. IPOS. It doesn't have to be in the correct order, but a program usually follows in that order. So input is our first step, and we're basically saying input or type in a number and store it into number 1. So instead of I, let me put, so this is step number 1. So say for instance we type in and we enter 10. Step number 2, the keyword is input, so that means we're typing something and we're storing it into the variable called number 2. We can type in 10 also. Step number 3, input, we're typing in a value, we are storing it in the variable called number 3. We are storing 10 also. I'm going to type in number 10. Now step number 4, the process is for me to add number 1 plus number 2 plus number 3. What value is in number 1? That'll be 10. What value is in number 2? 10. What value is in number 3? 10. Step number 5, output result of number 1 plus number 2 plus number 3. What is the result? The result is going to be 30. And then step number 6, end of pseudocode. Were you guys able to follow all that?
Yes, sir.
Amlino?
Sir, you lost me somewhere.
All right, let me go back from the top. So, let me write our own pseudocode. And then we can come back to that. So, a pseudocode always starts with a title. So, add 3 numbers. A pseudocode always starts with a title. Now, after that title, I would have said we can put the keyword start. This is optional to indicate that is the starting of our algorithm. Now, another useful thing we can do, or that we should do, is to number our steps. So we say step 1, and we can press the tab key so that we have an equal spacing, and start from that point there. So step 1, I'm going to use the keyword input and then the variable number 1. So remember we said that a variable, you would have learned that a variable is what we use to store our data. So the purpose of this program, this pseudocode, is to add 3 numbers. So obviously we gotta enter 3 numbers into the program. So when we enter these 3 numbers, where are we going to store them? That is why we created 3 variables. We created variable number 1 and variable number 2 and variable number 3. So at step number 1, we're simply saying we're using the keyword. Remember the keyword? We would have looked at keywords, and input and read are used as an indication that you are putting a number, you're putting a value, you're putting some sort of data into the computer. You're typing something into the computer, as we just learned here. Where is it? Yeah, as we just learned here, whenever we use the keyword input, is an indication that we're typing something on the keyboard. So by saying input, we're indicating that the person has to type something on the keyboard. Now, when the person types something on the keyboard, where are we going to store it? We are going to store it into this variable called number 1. If we don't have number 1 there, or we have nothing there, then whatever that person would have typed will not be stored, because we did not indicate where that input is going to go. So by typing input and then number 1, we are indicating that the person typed on the keyboard, typed a value on the keyboard, and then the value was stored in the variable number 1. So that there is what is being indicated by that step. Are you following me with the first step?
Yes, sir.
Good. So it's the same thing with step number 2 and the same thing with step number 3. You input, we use the keyword input to indicate that the person is going to type something, and we say simply where that data that person is going to type is going to be stored. That's why we create variables. So when you are going to create your pseudocode, and your pseudocode is going to say, like for instance, it says accept as input the names of the candidates, the votes received, then you have to use the same setup, the same guideline. You use the keyword input and say where that data is going to be stored. Now, so that there is the input parts. Now, the other part, step number 4, add the 3 numbers together. So, step 4, we, let's see, I think the next few steps, the next few steps would have summarized it. But step 4, at this step here, they're basically writing it in a descriptive manner. They're not actually using the exact guideline for a pseudocode. This is more descriptive. It's basically telling you, add 3 numbers together. Add number 1 plus number 2 plus number 3. And then step number 5 is indicating that we need to output. So remember we said here that outputs can be a soft copy on the screen of the monitor. So whenever we use the keyword output, yes, it's indicating that data is coming out of the computer, but in our case, it's more to indicate that the data is going to appear on the screen, because we're not creating any fancy program. It's just some simple programs that we're creating. So in our case, output is simply saying, put this on the screen. So the output the results of the addition before of adding number 1, number 2, number 3, simply output it on the screen and then end that pseudocode. Were you clear on the entire pseudocode?
Yes, sir.
All right. Oceana, you following?
Yes, sir.
All right, good. Now that same pseudocode is actually simplified further in the other examples. Now, if the next example is a way how we can summarize the pseudocode. So if the 3 variables, remember we have 3 variables here, that contain the 3 numbers have the same data type, for example, integer. Remember we looked at variables and data type. Each variable must have a data type. So if those 3 variables, number 1, number 2, number 3, had the same data type, then the statements to input the values can be placed on one line as the following. So in this example, once again, we have a title, add 3 numbers, but notice step number 1 is indicating that we need to input a value and store it in the variable number 1, and then input again and store it into number 2, and then input again and store it into number 3. This can only happen if they are the same data type. Only then you can summarize it into the same line. If they're not the same data type, for instance, if one of them was real and the other was integer, this cannot work. Remember we learned about those data types. Real and integer are both numbers, but different types of numbers. So if one was real, the other two was integer, you could not have written it in the same line. But because they are all integer data type, we can write it in the same line. Step number 2, the same processing step, but now it went up from step 4 to now step 2. Because remember, we try to summarize our steps. We try to make our steps as short as possible. That way we make a more efficient pseudocode. Step number 2, we add those 3 numbers together. Same as before. And step number 3, we output the result of that addition, and then we end the program. So because of that summarization, we went from 6 steps to 4 steps. Are we following this example here?
Yes, sir.
Oceano? All right, seems Oceana went away. All right, so now that we are familiar with variables, we can also place the result of the calculation in a variable. So we can further write it a little more in a more structured manner instead of being descriptive. So here we can say title, pseudocode, add 3 numbers. Step number 1, input and store it into those 3 variables. Step number 2 now is now basically a summarization of this step 2 and step 3. So now we say on the right hand side, add number 1, number 2, and number 3 and store it into the variable called results. And step number 3 now, we say output that result, or output whatever we would have stored in the variable called result. And step 4, we end that pseudocode. So it's basically the same as this one here. Does that we're no longer descriptive in our steps. We're now following a structured manner of creating that step. We're now using the keyword and the variable only. Are we clear on how this pseudocode was created?
Yes, sir.
All right. Now, let's see. All right. All right, so the new variable result on the left side of the statement will contain the answer from the calculation of the numbers from the right-hand side. So remember I told you guys that in programming, we usually write it in this manner. Our calculation on the right-hand side, and then this can either be an arrow or an equal sign. And it's indicating that we are storing the answer on the right-hand side for the right-hand side on the left-hand side. So add up everything on the right, store it on the result in the left. So calculation can include a left arrow or the equal sign to indicate that the result of a calculation is stored in a variable. Any questions? Oceania, back with us? All right. All right, so before we continue, there is something that the textbook does not show us that we need to add to our pseudocode. So right after the start, we need to do what is called variable declaration. We need to tell the system what variables we're going to use before we use them. So like how we used in this example here, the variable called number 1, the variable number 2, and the variable number 3. Technically, we cannot just go and use a variable because we did not declare that variable. We did not tell the system that we are going to use that variable. So it's like if well, can't think of an example right now. But basically, we cannot use it unless we tell it that it exists. So how do we do that? It's a simple process. Variable declaration. So it's variable name equal data type. That is how you declare a variable. You indicate what is the variable name and you indicate what data type it is being set as equal to. So in this case here, is going to be number 1 equal integer. Number 2 equal integer. Number 3 equal integer. And that is how we declare these 3 variables that we're going to use. Now, based on what we just learned, how could we summarize this 3 line here? How do you think we can summarize it? How do you think we can summarize this 3 line, this declaration here, into 1 line? Remember what we did here? We did step 1, 2, and 3. It has input and then a variable, and then we summarized it. We used the keyword input, and then we wrote the variables in the same line, and that's simply because they were the same. So similarly, we could say number 1, comma, number 2, comma, number 3 are equal to integer. And that's how we can summarize it. Those 3 variables are equal to the same data type. You guys think you're following?
Yes, sir.
Sure.
Yes, sir. But why did you not put add or something in the line?
Why didn't I?
Like put add number 1, number 2, number 3.
Where?
You see, in the example you showed us had add. Yeah.
This one here?
Yeah.
Like this here?
Yeah.
Still don't understand what you're referring to.
Why did you not put add in front of number 1?
In this exact example here,
Yeah.
why did they put add in front of number 1?
They have add there, right? Why you didn't put it in your Word document?
Because I finished it as yet.
Oh.
And remember, we're now talking about declaration right now. So this is the declaration section. So let me indent that. That's the declaration section. But this here is what you're more talking about. So so let me or inputs number 1, number 2, number 3. So that either that can work. Now step 4, we need to add those 3 numbers together. So this is what you're talking about. So result, I'm going to do the summarize method because this is what I also want you guys to follow. So number 1 plus number 2 plus number 3. And then step 5, we outputs what is inside of the value results. And then we end. So this here is the steps for our instruction. We use the keyword input to indicate we are going to store it into the variable called number 1, number 2, number 3, or we can summarize it as input number 1, number 2, number 3 in the same line because we would have declared they are the same data type. So remember, we can only do that if they are the same data type. Now, so step number 4, calculation on the right hand side. We add the 3 numbers together, number 1 plus number 2 plus number 3, and then we store it into the variable results. Now, let me see if you guys can figure out what's the issue. What's the issue with number 4? What is the issue with number 4?
It ain't supposed to be the result.
Yeah, it's supposed to be
I mean,
result.
it's supposed to be the processing part. When we input the three numbers, right?
Mm-hmm.
Why would we get the result next? The result is supposed to come last.
All right. All right. Here's what. The I hear the eclipse just starts. So just give you a couple of minutes. Let me go and see. Check it out. Yeah. So let me continue. All right. Amelina, let me start from the top. So remember we're looking at how to create a pseudocode. So the first thing all pseudocode must have is a title. So that's what we have at the start here. Now titles are used to indicate that that is the starting point. But as we said, you can put the keyword start if you want, that's optional. Now, technically, you're supposed to start with variable declaration. All the examples you're going to see, they jump straight to the steps of the pseudocode. But we are supposed to actually start with a part of the pseudocode called the variable declaration, where we have to indicate to the system what variables we are going to use and what data type they are. Because if we do not declare them, we cannot use them. So this is how we declare a variable. You state the name and you state the data type. So for example, variable number 1, we declared it as a integer data type. Number 2, we declared it as integer also. Number 3, as integer also. Or we could summarize it into one line because it's the same data type. Number 1, 2, and 3, separated by comma, is equal to integer. They're all the same data type. Clear so far?
Yes, sir.
All right, Oceana, I see you're finally back. All right, so step number 1 now. At this stage here, step number 1, this is the actual steps that we have to carry out for the program. So step number 1, we're indicating with the keyword input, the person has to type something in, and we're storing it in a variable called number 1. That's what is step number 1, 2, and 3. Or, because it's the same data type once again, we could say input or type in a value, and we're going to store it into these 3 variables here. So when you type in the first value, you press enter, it's going to be stored in number 1. When you type in the second value and press enter, it's going to be stored in number 2. When you type in the third value and you press enter, it's going to go to variable number 3. And then it automatically starts step number 4. Now step number 4 is for us to add those 3 numbers together, number 1, 2, and 3, and then store it in the variable on the left hand side called results. Now let's pause there. Why the question is, what is the issue with step number 4 and the overall pseudocode? What's the issue? There's an issue. And step number 4 will not work. Why is that? What issue is there with step number 4?
Sir, there is no output.
We reached that stages yet. Forget about the output. We're pausing at step number 4. Just looking at step number 4. There's an issue with step number 4 and going backward. Let me give you a hint. As I said when I started the explanation, what must we do with all variables? What must we do with all variables? It's like literally there, just watching you.
Put in the data type.
Put in a data type. And that is what we call variable declaration. So simply, all variables, and I mentioned it again, must be declared. All variables must be declared before they can be used. Is the result variable declared?
No, sir.
No, because we do not see it at the top here with a data type. So now I am declaring that variable results equal integer. So now step 4 can work because now I would have declared or ensured that that variable was declared. Are you guys following, Amelina?
Yes, sir.
Good. Now we can introduce back step number 5, where we say output or put on the screen whatever is inside of that variable called result, and then end the pseudocode. I want you guys to have a look at the overall of this pseudocode here. Run through it, ensure you're clear on it. This is a simplified version, not a simplified version, but this is actually a complete pseudocode. This is actually a complete pseudocode. Something that you actually have to create. You will have to create after your IPO chart. This is everything that you will practically need for your pseudocode, except one part. We can look at that part just now. So once again, a pseudocode starts with a title, the word pseudocode colon, and you create a title. You could put start or begin, that's optional, that's up to you, but the title is usually indication of start. The next stage of your pseudocode is the variable declaration section. You must tell the system what variable and what data type is that variable before you use it. You must do that. And then we head into, actually from this point here, we could have the starter begin, because this is the actual starting of our steps. If you want to put start there, no problem also. So from this point here, we start our steps. Our step 1 to 3, where we enter our numbers. So this is exactly the pattern that you can follow whenever you want to input a value. Whenever you want to store something, you use the keyword input and what variable is going to be stored into. When you want to calculate something, this is how you do it. Right hand side has the formula. And when you get the result of that formula, where are you going to store it? You say, you put the name of the variable and an equal sign. And whenever you want to output something from a variable, you use the keyword output and whatever that variable name is. These are the general guidelines you can follow when creating a pseudocode. Are we following?
Yes, sir.
Oceano?
Yes, sir.
All right. Any questions at all?
No, sir.
All right. So here is yet another set of pseudocode. For example, example 5, using different keywords to read. So instead of input, we're going to use the keyword read and print instead of output. Because remember, those keywords are interchangeable. The keyword end could also be used on its own to denote the end of the statement. So the same pseudocode, just with different keywords. You have a title, pseudocode 5D, add 3 numbers. Step number 1, you're going to read or input, store it into number 1, store it into number 2, store it into number 3. Store it into those variables. Step number 2, you carry out your calculation on the right-hand side, add the 3 numbers together, and store it into the variable called results. And then step number 3, you print or you output whatever is inside of the variable called results. And then we end our pseudocode. Are we clear in this here, this example?
Yes, sir.
All right. Now, before we continue, there's something I want you to adapt or copy. If you notice what I am doing, whenever I'm going through the pseudocode, I'm marking and I'm writing in that pseudocode, it's not only because to teach you, but it's also to follow the pseudocode properly. So remember, we're preparing to create the SBA, but at the same time, we're also preparing to write CSEC. Now, in your exam, they can give you examples, and they will give you examples of pseudocode. And you will have to do what is called tracing. That's the correct terminology, tracing that pseudocode. You're basically going through it step by step. You're tracing it, going through that pseudocode step by step. And what they can do is ask you certain questions like what value does the variable have at step number 3? What value does the variable have at step number 5? Things like that. So by following the same pattern that you see that I'm doing, marking what actions are going to be carried out, whenever you see a variable, write down what value that variable has, because you can't forget. So by writing it down, you'll be able to remember what value that variable has, so you can know at what stage of the pseudocode what value it contains, and you'll be able to answer any question that it might have. And it gets even more complicated because we're only running this pseudocode once. What if we had to do it 2 or 3 or 4 different times? Because remember, we're also learning about loops. We're going to be learning about loops. And a loop is when you repeat something. So they will give you a program, a pseudocode, where it has certain parts it has to repeat itself. So you have to know now if maybe on the second loop, they can ask you a question like that. On the second loop, what value does step number 3 have? And only by learning how to trace the pseudocode properly will you be able to tell exactly what value it has. So that's the advice I wanted to give you. Try to copy the pattern as to how I am tracing a pseudocode. You write down, you draw, you indicate what is actually happening so that you can remember. All right, so another term is that we're going to be looking at is called sequential statements. Now, this is just a, it's not anything that you create. It's something that you do naturally. It's something that happens naturally when you create a pseudocode. And the term for it is called sequential statement. What does the word sequential mean? What does the word sequential mean?
Logical order.
Logical order, good. Or basically something that happens one after each other, and as you said, it happens in a logical order. So if you notice, that's why we're actually numbering these steps. Step 1, step 2, step 3, step 4. That is a logical order. So that's what's meant by sequential statements. The statements, remember these are all statements. Each line is a statement. And then it basically indicates what action is being carried out and so on. So each statement is happening in a logical manner. It's occurring in a logical manner. Step 1, line 1 will always occur before line 2. Line 3 will always occur after line 2. Unless there's something indicating otherwise. But in a normal pseudocode, it always carries out what is called sequential statements. And that is statements that are executed one after the other from the first statement to the last. That is simply what is meant by sequential statements. It carries out one statement after the other in a logical manner, from step 1 to step 2, step 3, step 4, until the end of the program. It's always one after each other. All right, so let's look at one final example of a pseudocode, and then we'll wrap up here for the day. So once again, we're started from an IPO chart. We have two variables. Variable 1 is max temperature. Variable 2 is minimum temperature. Now the process is for us to calculate by adding max and min and then dividing that by 2. And then we output the variable called average temperature. Now if you notice, there is no average temperature equal that, but it's indicated, but it's not fully indicated. But in our case, we should have written it that way. Average temperature equal and then the formula on the right hand side. All right, so let's look at the pseudocode now. So we have a title, pseudocode 6a, find average temperature. So notice the title is always descriptive, telling you exactly what the pseudocode is doing. Step number 1, input. Input is the keyword to indicate you're typing something. So we're typing something into the variable called max temperature, and we're also typing something into the variable called min temperature. Now once again, notice there is no declaration, but more than likely, what would the declaration be for these variables? If you were to declare it, tell me how you would declare it.
Max temperature would equal to integer.
All right. Are you sure integer is going to be the correct data type?
Or it would be real,
And why real?
because it's a number, sequence of numbers.
No. What's the difference between real and integer?
Real has fractional numbers. Integer has whole or real numbers.
Good. So which would be more appropriate for temperature? Whole number or fractional numbers? Or decimal numbers? Whole number or decimal number? Which would be more appropriate?
Decimal numbers.
Right. because you could have a point something for the degree, right?
Yes, sir.
Good. So max temperature is equal to real. And we could summarize it, max and min are equal to real. Amelina, you following?
Yes, sir.
Good. So that's how we declare, right? So max and min are real. What about average? Average temperature, how would we declare that? What data type would that be?
Real.
Real. Because obviously, if you're already using decimal numbers, then your result is going to be a decimal number. So this can be, with this in mind, this is something you should take note of. If your base numbers, which is basically your max and min, if your starting values, the values that you're using are already in a decimal format, you cannot store it into a whole number. The system will not allow it. So I cannot say now that average temperature is an integer. That will cause an error in the system because it will not know what to do with the decimal part of the number. So it's going to cause an error. Because remember, the decimal part is part of the number. So you cannot take real numbers and store it into integer numbers. It must always go into a real. Think you guys following?
Yes, sir.
But what about the reverse? Do you think if this was integer, could I store that into a real data type?
No, sir.
Why not? Think about it logically. Because
The
it's
decimal,
yeah, go ahead.
the decimal would just be 0.0, and that would make sense.
Yeah, it won't make sense, but would it cause an error if something is
No.
0.0? No. So that's what I mean. Think logically. If it's a 0.0, it won't cause an error. It won't have a difference in meaning. So this here can work. You can go. It's basically if it's logical. If it can work in terms of if the data is going to make sense. So like say for instance you have 10 plus 20, then that's integer. Then you can store it into a real, so that's going to be 30.0. Nothing's wrong with that. Nothing's wrong with having 30.0. But if you're going to have 5.5 plus 5.6, then that's going to be, and you try to store that into an integer, then that's going to take out the decimal part, and that's going to give us 11, because technically it's supposed to be 11.1, but that's going to give us 11. But it's not the actual value because there's still a missing 0.1, and that's part of the number. So that's going to cause an error in the system because part of the data was actually removed in that process in trying to go from real to integer. So that's why from integer to real can work because the 0.0, nothing's wrong with that. It's not affecting anything. But when you go from real to integer, you're actually taking away from the data. So that's why it would not work. Clear on that?
Yes, sir.
Good. So, good. So input, we store it into max and min. Step number 2, we carry out the calculation on the right-hand side. We add max and min divided by 2. We store it into average, and then we output average temperature. And then we end our pseudocode. Any questions on this example here?
No, sir.
All right. Any questions overall? Any questions in general? Because we're going to wrap up here for today.
No, sir.
All right. So to review what we would have looked at today, remember I gave you 2 tasks. You have to start your IPO chart. All the information is in this paragraph here. And you also have to start your problem statements with this guideline here. This is just a guideline. So if you want to add more to it, no problem. So what we looked at today is that we looked at how to create a pseudocode basically. And I gave you a general guideline here also. I'll send you this document. A pseudocode always starts with a title. So title. And the next step is for you to declare your variable. And then we actually start the steps from that point. Next week or sometime in the future, we're going to learn about variable initialization, because that usually comes after declaration. Variable initialization. That's actually the next part. But some programs don't have it. Some programs do have it. So it's an optional part. It's only if the program needs it. So this part is actually an optional part. Only if the program needs initialization. So we're going to look at that in the next class. Well, we looked at you have to declare in a pseudocode to tell the system what variable and what data type you're going to use. Initialization, we're going to look at that later on. And then you basically have your steps from starting to end, and you end your pseudocode. Next week, we're going to also start from conditional branching or conditional statements. Any questions before we close?
No, sir.
All right. If no questions, that will be it for today's class. Enjoy the rest of your day.
Yes, sir.